Hello students, in this video I am going to discuss the robot anatomy, classification of robot and specification of robot. The robot anatomy, if you take the already in definition we said that the robot is compared with the human. How human you have a shoulder, elbow, wrist and a palm, finger, everything. Similarly, robot also have a similar thing. For example, you take this picture, you have a waist. With respect to waist, it will the robot entire structure can rotate, and here it will be like a shoulder. This is called elbow. This is a wrist. Then this will be like palm and fingers. Okay. So up to this, it is called manipulator. Here it is called end effector. Okay. Now I am coming to the text part, the physical construction of the body, arm, wrist of the machine. So this is comparable. The wrist is oriented in a variety of position such that in wrist you can add different tools. Like for example, you can use welding gun, you can use the spray painting gun, like that. Anything you can fix. The relative movements between various component of the body, arm, wrist are provided by series of joint. For example, this is one joint, right? Link one, link two, connected with one joint, what is called shoulder. This is link one, link two. Second, link two and link three connected with elbow. Then finally, the in wrist position here, tool and wrist position, it is connected with the third joint. So joint one, joint two, joint three. Three joints are there. Series of joints, and so this is the way the relative movements are provided. Joints are provided either sliding or rotation. For example, it will take a sliding movement with respect to shoulder. It will take up and down movement. Whereas with respect to elbow also, it will take up and down movement. Whereas with respect to weight, the robot entire structure, it will swirl. Swirl means rotating about the vertical axis. Here, finally, there is a word what is called a manipulator. It is called assembly of body, arm, and wrist are called as a manipulator. Right? Manipulator means assembly of the body, arm, and wrist. Next, coming to robot anatomy, three here up to this manipulator, this particular portion is called end effector. You have a gripper, everything, and here bottom it is called locomotive. Here you have by using electric, hydraulic, pneumatic energy is used to operate the robot. Here coming to the specifically manipulator consists of joints and links. So this is called links and joint. Two links are connected, pinned with one joint. Links are rigid member between the joints. Various of types of joints are there. So some joints it is made for linear movement, sometimes for rotary movement. Here with respect to weight, you will get a rotary movement. Here you will get a linear movement. So most of the robot you have 5 or 6 degrees of freedom. 5 or 6 degrees of freedom means the degrees of freedom means various possible movement. For example, you take degrees of freedom throughout the space. You have three axes x, y, z. For example, if you take right left movement as a x-axis, then similarly right left, right one movement, left one movement, two movement with respect to x-axis. If you take y-axis, front movement and back movement. This movement is with respect to y-axis. Similarly, z-axis up movement and down movement. So totally 6 degrees of freedom. This is called the degrees of freedom. Sometimes some robot it will have some Cartesian robot like Robo. It will follow only linear movement. Some robots it will take linear plus rotation combination. Next, I'm coming to the classification. Here, classification you can classify with respect to degrees of freedom, kinematic structure, drive technology, work space geometry, and motion characteristics. General purpose here, general purpose you have. I mean, with respect to degrees of freedom, you have general purpose, redundant, and efficient. General purpose means you have at least degrees of freedom. Redundant robot means more than 6 degrees of freedom. Sometimes all the linear movements, in addition to linear movement, some rotary movements will be provided. So what is called redundant, more than six. Some deficient robots also there. It is like less than 6 degrees of freedom. For some industrial applications, sometimes if floor height, ceiling height is very less, Z plus movement will not be permitted. So that time Z plus movement is arrested. So that time we will get only 5 degrees of freedom. Then classification with respect to kinematic structure, you have a open loop parallel manipulator. Open loop, sometimes it is called as a serial manipulator. This will be kinematic structure. It will look like a C type. So this structure normally it is not having much rigidity. Whereas parallel manipulator, you will get a rigid structure. You will get greater rigidity, higher payload, higher stiffness, lower inertia. These are all. Best example is Delta robot. Then you have another manipulator, hybrid manipulator. It is widely used for industrial application. Of course, it is called industrial robot. This is the combination of open loop and a parallel manipulator. Then coming to classification with respect to the various movement characteristics according to the design. Sometimes it will make a planar manipulator, spherical, then spiral. Planar means it will be like a linear. This will be like a spherical, something which is not covered. Some movement we are not linear, not rotary. This is comes under another third category. This slide I added for the misconception in the syllabus word. They are giving classification, coordinate system and control system. Coordinate system means you have a Cartesian, cylindrical, spherical. We are going to discuss. Of course, this is a basic structure. Two more is there. So next slide I am going to discuss. And control system, you have a open loop, closed loop. Normally open loop, you will not get any feedback from the mechanism. Whereas closed loop, you will get the feedback with respect to environment or a task. You will get a continuous feedback. Now I'm then another important thing. This is important for 2 mark question or something. Degrees of freedom. It will be mentioned like this. Three words: pitch, yaw, roll. You can remember PYR movement. For example, if you take pitch here, this is a pitch, yaw, roll. Pitch, it will take a up down movement. With respect to this axis, the both structure it will move up and down. Whereas you take yaw, this particular joint, yaw joint, you will have a right left movement. That means this part it will take right left movement, and finally roll means rotary movement. This will be at the end, it will get rotation. This is called typical degrees of freedom. It is used in various end effectors. And you have another concept is called what is work volume. Work volume means maximum volume occupied by the robot. For example, if you take a polar coordinate system, it will be like a spherical shape. If you take a cylindrical one, you will get a cylinder like this. And a Cartesian, it will be like a rectangular block. Now I'm coming to the robot configuration. So this is previously we explained like a coordinate system. Cartesian means all are linear movement. Here, for example, you take right left movement, front back movement, upward movement, Cartesian robot. Cylindrical robot, one rotary movement, one upright up down movement, then front back movement. It is there, right? Two linear, one rotary movement. Cylindrical. This work volume is like a rectangular. Previous slide we have seen. Cylindrical robot, it's like a cylinder. Whereas a polar, you will get a spherical. For example, with respect to base, it will rotate about 360 degree. This link with respect to this, it will make a swing action, up and down movement. Here, it will take front and back movement. Coming to angular movement with respect to base, it will rotate. This is another rotation. This is for it is not like completely linear or completely rotary movement or swing movement. It is different. This is possible for various angular movement. Coming to SCARA robot, it is widely used widely used for assembly purpose. Here, two rotary movement, one linear movement will be there. With respect to base, it will rotate. And here you have another link, it will rotate like this, and up and down movement also provided. Coming to robot configuration, again same thing. All are linear movement. One workplace example it is given. Cylindrical robot on pictorial representation is given for students' understanding. Two linear movement up and down, front and back, and rotary movement is given. Here, robot configuration, spherical joint, you will get a front back movement, and here it will make a rotation. With respect to base, it will take a rotation, and here, with respect to this link, it will swing up and down. You refer the photographic view for better understanding. This is for a articulated robot. This is for providing various angular movement. With respect to base, it will rotate. And again, here you have a swing moment. The middle link, it will get a swing moment. With respect to this joint, it will take a up and down moment. Again, this is called a SCARA robot. It is widely used for assembly purpose. Here, two rotary movement and one up and down movement is provided. These are all the various coordinate system, or sometimes it is called various configuration. Coming to specification, there are two specification. One is with respect to common robot, you have a specification. Industry robot, you have other specification. For example, joint variable, relative displacement between the adjacent link is one of the specification. And every end effector, what kind of gripper you are using, what type of tool you are using for various purpose. Degrees of freedom, already I said, various movement. So minimum 6 is required. And what kind of configuration we are using, whether it is a polar, cylindrical, Cartesian like that. And the configuration